In the sweltering heat of the 1950s Cold War, the United States Air Force was haunted by a single, terrifying logistical problem: how to keep a fleet of strategic bombers in the air indefinitely, ready to strike at a moment's notice without ever needing to land for fuel. Their solution was as brilliant as it was insane. They decided to take the largest aircraft ever built, the 10-engine Convair NB-36 Peacemaker, and install a fully operational, unshielded 3-megawatt nuclear reactor in its rear cargo bay. This was the Convair NB-36H, a machine that was effectively a flying atomic furnace. It wasn't just an airplane. It was a flying Chernobyl, a 180-ton aluminum beast that turned the very air passing through its engines into a radioactive wake. When this monster took off from the tarmac in Texas, it didn't just carry the threat of nuclear war in its bays. It carried a core of pulsating uranium that could contaminate an entire state if it suffered a single mechanical failure. The sheer audacity of the NB-36H project defied every law of conventional aviation safety. The reactor, known as the Aircraft Shield Test Reactor, was a 16-ton cylinder of pure radioactive fury. Unlike a ground-based power plant, this reactor had to be light enough to fly, but powerful enough to test the limits of radiation shielding. To protect the crew from being liquefied by gamma rays and neutrons, engineers had to build a specialized 12-ton lead-lined coffin at the very front of the plane. This wasn't a standard cockpit. It was a hermetically sealed vault made of solid lead and rubber, with windows made of thick, yellowed leaded glass. The pilot sat in a cramped, oppressive silence, separated from the screaming reactor by nearly 50 meters of fuselage and a massive shield of water and steel. They were flying a laboratory of death, and every time the Geiger counters in the cockpit began to tick faster, the men inside knew they were just one structural crack away from an agonizing end. But the most disturbing part of these test flights wasn't the reactor itself. It was the secret red telephone protocol that was activated every time the NB-36H left the ground. Subscribe to the channel, hit that like button, and stay with us until the very end, and you will discover the horrific suicide clause in the crew's contracts and the hidden fleet of elite paratroopers that followed this plane on every single mission, carrying a terrifying order to be executed if the reactor ever touched the soil of the United States. If you want to understand the madness of the atomic age and see the machines that were too dangerous for the human race to handle, you are in the right place. We are going deep into the radioactive heart of the Crusader. The mechanical complexity of the NB-36H was a nightmare of mid-century engineering. The aircraft was powered by a staggering combination of 6 massive Pratt & Whitney R4360 radial engines and 4 General Electric J47 turbojets. This 10-engine configuration was necessary to lift the immense weight of the lead shielding and the water-filled cooling tanks. The vibrations produced by these engines were so powerful that they threatened to shake the reactor's control rods out of alignment. Engineers spent thousands of hours trying to dampen the resonance of the airframe, fearing that the Peacemaker would literally shake itself into an atomic meltdown mid-flight. Inside the lead capsule, the pilots were completely isolated from the rest of the aircraft. They had no physical access to the rear of the plane. They were locked in their 12-ton sanctuary, communicating via radio with technicians who were monitoring the reactor's temperature and neutron flux from behind massive shielding. Flying the NB-36H over the American Southwest was like walking a tightrope over a pit of fire. The Air Force had to establish secret Zone X corridors, flight paths over sparsely populated areas of New Mexico and Texas, just in case the plane fell out of the sky. Every flight was shadowed by a C-119 transport plane carrying a team of armed paratroopers. Their mission was not to rescue the crew, but to immediately cordon off the crash site and prevent anyone, including local police or civilians, from approaching the radioactive wreckage. The pilots knew that if they went down, they wouldn't be heroes. They would be the center of an environmental catastrophe that the government was prepared to cover up at any cost. This constant psychological pressure turned the cockpit into a pressure cooker, where every alarm bell could mean the end of a city. The heat generated by the reactor was another silent enemy. Because the aircraft utilized an open-loop cooling concept during some phases of testing, the air was drawn in, heated by the reactor core, and then expelled. This made the NB-36H a literal cloud maker, leaving a trail of ionized air behind it that could be picked up by Soviet sensors thousands of miles away. It was a machine that couldn't be hidden, a glowing target in the sky. Maintenance crews on the ground had to use remote-controlled robotic arms and 10-meter-long tools to service the aircraft after it landed because the metal skin of the plane would stay hot with residual radiation for days. The NB-36H wasn't just a vehicle, it was a permanent hazard, a piece of technology that treated the Earth and the sky as its own private dumping ground for nuclear waste. The true horror of the NB-36H Crusader lay not just in its power, but in the total isolation required to keep its crew alive. To understand the scale of this mechanical nightmare, one must look at the lead coffin cockpit, a 12-ton pressurized capsule that was entirely separate from the rest of the airframe. This wasn't a standard fuselage, it was a fortress within a plane. The engineers at Convair were forced to replace the entire nose section of the B-36 with a massive structure lined with 4 inches of solid lead and 6 inches of specialized radiation-absorbent rubber. The windows were made of high-density leaded glass, so thick and heavy that they had a permanent yellow-green tint, distorting the pilot's view of the horizon. Sitting in that cockpit was like being buried alive in a submarine that was flying at 30,000 feet. Every breath the crew took was filtered through specialized air scrubbers, as the military was terrified that radioactive isotopes from the reactor at the back could be sucked into the air intakes and settle in the pilot's lungs, killing them from the inside out before the mission was even halfway over. This was a machine that defied the logic of 1950s aerodynamics. To lift the massive weight of the shielding and the reactor, the NB-36H had to operate at its absolute structural limit during every single takeoff. The 6 massive R-4360 radial engines, the most powerful piston engines ever made, would scream at full throttle, their 28 cylinders each pounding with the force of an industrial hammer. The heat generated by these engines was so intense that the magnesium alloy wings were constantly at risk of catching fire. But the real danger was the acoustic resonance crisis. The combined noise of the 6 propellers and 4 jet engines created a vibration frequency so violent that it began to microscopic cracks in the lead shielding. If the shield cracked, the crew would be hit by a concentrated beam of radiation as sharp and deadly as a laser. Technicians would spend days after every flight using ultrasonic scanners to check for hot leaks in the cockpit walls, knowing that even a pinhole-sized failure meant the pilots were already walking dead men. The reactor itself was a marvel of destructive potential known as the open-loop experiment. While later designs planned to use closed pipes to transfer heat, the NB-36H was testing how radiation interacted with the aircraft's very structure. This meant the internal bays of the plane were constantly bathed in a lethal glow. Any piece of equipment located behind the lead shield, the hydraulic pumps, the electrical wiring, the fuel lines, became radioactive over time. This process, called neutron activation, literally changed the molecular structure of the airplane's aluminum skin. The plane was becoming a giant battery of radioactive waste. This led to a terrifying problem. The longer the NB-36H flew, the more dangerous it became to its own ground crew. It reached a point where even when the reactor was turned off and lowered into its protective ground pit, the empty aircraft was still hot enough to trigger Geiger counters from 50 yards away. The NB-36H was a ghost that left a trail of poison everywhere it touched, a mechanical predator that couldn't be cleaned and couldn't be hidden. Inside the reactor core, the uranium fuel rods were subjected to G-forces that no ground-based reactor was ever designed to handle. During turbulence or steep turns, the liquid coolant inside the reactor would surge, creating a reactivity spike. The scientists on board had to manually adjust the control rods with agonizing precision, knowing that a single surge could lead to a prompt criticality event, a flash of blue light and a burst of radiation that would instantly kill everyone on board and turn the aircraft into a flying dirty bomb. This created a state of constant, high-alert panic among the reactor technicians. They weren't just monitoring a machine, they were wrestling with a nuclear beast that wanted to break free. They lived with the knowledge that if the 10 engines ever failed simultaneously, the reactor would have no way to cool itself. Within seconds, the core would melt through the bottom of the plane like a white-hot knife through wax, raining molten uranium down on the American heartland. The psychological toll on the crew was immense. They were given radiation film badges to wear on their flight suits. But many of the pilots believed these were useless, mere psychological tools to keep them from realizing how much exposure they were actually getting. There were rumors of a red line limit, a secret amount of radiation a pilot could absorb before he was permanently grounded and moved to a desk job to hide the physical symptoms of his service. The Air Force tried to mask the danger with patriotic propaganda, calling the project the Crusader. But the men who flew it had a different name. They called it the Terminal Express. Every time they climbed into that lead-lined tomb, they were acutely aware that they were part of an experiment that treated human life as a secondary concern to the goal of nuclear dominance. They were the first and last generation of atomic aviators, flying a machine that the world was lucky never to see in mass production. As the program progressed, the military began to realize that the NB-36H was a strategic dead end. The weight of the shielding made it impossible for the plane to carry a significant bomb load, and its low speed made it an easy target for the new generation of Soviet supersonic interceptors. But the project wasn't canceled because of its military failure. It was canceled because of the ground impact projection. Computations showed that if an NB-36H crashed near a major city like Dallas or Denver, the resulting radioactive plume would force the permanent evacuation of hundreds of square miles. The United States was essentially flying a weapon that would cause more damage to its own territory in an accident than an enemy could achieve in a conventional strike. The dream of the nuclear-powered bomber was dying, but the mechanical corpse of the NB-36H still had secrets to tell, secrets that remained classified for decades under the highest levels of national security. The logistical reality of operating the NB-36H Crusader was a descent into a specialized form of military madness. Every time this radioactive titan prepared for takeoff, the entire airspace of the testing corridor became a zone of silence. This wasn't just to keep the project secret from Soviet spies, it was a desperate safety measure. The U.S. Air Force established a massive ground and air network designed for one purpose: to handle a crash that they knew would be catastrophic. A fleet of C-119 transport planes followed the NB-36H on every single flight, carrying elite paratroopers and radiation specialists. Their orders were chillingly clear. If the 10-engine monster began to fall, they were to jump immediately and establish a perimeter, using lethal force if necessary to prevent any civilian, reporter, or local authority from witnessing the melting remains of a nuclear reactor in the American dirt. They were a cleanup crew for a disaster that the government hoped would never happen, but was mathematically certain if the project continued. The complexity of the ground operations was even more extreme. The NB-36H could not be stored in a standard hangar. The radiation emanating from its fuselage, even when the reactor was shut down, was so intense that the airframe itself became a source of secondary radiation. This led to the construction of a subterranean shielding pit at Convair's Fort Worth facility. Upon landing, the plane would be taxied over a massive, reinforced concrete hole in the ground. A specialized remote-controlled crane system would then reach up, unlatch the 3-megawatt reactor from the aircraft's belly, and lower it into a lead-lined vault deep underground. Only then could the lead coffin cockpit be opened to let the exhausted pilots escape. The ground crews who serviced the rest of the plane had to wear heavy protective suits and use robotic arms through thick shielding walls, treating the world's most advanced bomber like a piece of high-level nuclear waste. Every bolt tightened and every engine tuned was a brush with invisible death. But the most terrifying engineering challenge was the cooling failure paradox. In a traditional nuclear plant, thousands of gallons of water are available to prevent a meltdown. On an airplane, weight is everything. The NB-36H relied on an experimental air cooling system that was prone to atmospheric choking. If the aircraft flew into a swarm of birds or encountered heavy icing, the cooling intakes could become blocked. In such a scenario, the reactor temperature would skyrocket in seconds. Because there were no massive containment domes in the sky, a meltdown meant that white-hot radioactive fuel would liquefy the aluminum floor of the bomber and rain down as a glowing liquid fire. Engineers lived in constant fear of a low-altitude stall, where the air pressure wouldn't be sufficient to push enough oxygen through the cooling vents. The pilots were effectively flying a machine that was constantly trying to melt itself from the inside out, a balancing act between aerodynamic lift and thermal destruction. As the program moved into its late stages, the material fatigue crisis began to set in. The constant bombardment of neutrons from the unshielded reactor was literally changing the molecular structure of the aircraft's high-strength alloys. The aluminum skin was becoming brittle, a process known as radiation embrittlement. Inspectors began to find microscopic fractures in the primary wing spars, the very bones of the aircraft. This meant that the more the NB-36H flew to prove its worth, the closer it came to snapping in half mid-air. It was a race against time. Would the military master nuclear flight before the plane itself disintegrated under the weight of its own radioactive legacy? The secret reports from this era describe a growing sense of dread among the high-ranking officers. They realized they had created a doomsday bird that couldn't be repaired, couldn't be easily scrapped, and was becoming more unstable with every hour of flight time. The final missions of the Crusader were conducted under a cloud of increasing tension. There were several near-miss incidents that were scrubbed from the official records for decades. On one flight, a massive fire erupted in engine number 4, a radial piston engine located dangerously close to the reactor's cooling ducts. The crew had to make an emergency shutdown while the Geiger counters in the lead capsule began to scream. For 10 agonizing minutes, the pilots struggled to maintain altitude, knowing that if they crashed, the impact would shatter the reactor vessel and create a permanent dead zone in the heart of Texas. They managed to land, but the incident proved that the NB-36H was a ticking time bomb. The nuclear dream was turning into a logistical and environmental nightmare that no amount of Cold War bravado could justify. By 1957, the arrival of the Intercontinental Ballistic Missile, ICBM, finally provided a cleaner, cheaper, and safer way to deliver nuclear death. The need for a bomber that could stay in the air for a week disappeared overnight. The NB-36H was quietly retired, but its disposal was as complex as its creation. It couldn't just be sent to a boneyard. The radioactive sections of the plane had to be buried in specialized deep earth trenches, and the lead coffin was stripped of its secrets. The era of the atomic airplane ended not with a bang, but with a silent burial. However, the data gathered from those 47 terrifying flights remains some of the most guarded information in aviation history, a record of what happens when humanity tries to put a star inside a tin can and teach it to fly. The death of the NB-36H project was not a clean military exit. It was a desperate attempt to bury a mistake that had become physically dangerous to handle. By 1958, the nuclear Crusader was no longer a symbol of progress, but a radioactive liability that the U.S. government wanted gone. But you cannot simply scrap an airplane that has been irradiated by a 3-megawatt reactor for years. The aluminum airframe had undergone a process of isotopic transformation, meaning the metal itself was now emitting radiation. The disposal of the NB-36H became a secret operation of unprecedented scale. The aircraft was dismantled in high-security exclusion zones, with the most radioactive sections, the rear fuselage and the reactor housing, being cut into pieces and buried deep within lead-lined trenches in the desert. The giant that once aimed to conquer the skies ended its journey as a buried secret, a mechanical corpse that will remain lethally radioactive for thousands of years. But the true horror of the NB-36H's legacy is what came immediately after it: Project Pluto. While the NB-36H was designed to carry a reactor as a power source, Project Pluto aimed to create a nuclear-powered ramjet cruise missile that would fly at Mach 3, spewing unshielded fission products directly into the air behind it. It was the logical and much more lethal evolution of the flying Chernobyl concept. The engineers who worked on the Crusader provided the foundation for a weapon so terrifying that it was nicknamed the Flying Crowbar, a machine that would kill everyone on its flight path simply by passing over them. The NB-36H proved that nuclear flight was possible, but Project Pluto proved that nuclear flight was inherently genocidal. Thankfully, like its predecessor, Pluto was eventually deemed too dangerous even for the heights of the Cold War, as American generals realized there was no way to test such a weapon without poisoning their own continent. As we look back at the rusted, buried remains of the NB-36H, we must confront the technological blind spot of the 1950s. This was an era where the military believed that any problem, no matter how complex, could be solved with more power and more mass. The lead coffin cockpit is a perfect metaphor for this philosophy. It was a 12-ton admission that the machine they had built was fundamentally incompatible with human life. It was a time when the sky wasn't seen as a fragile ecosystem, but as a vast, empty battlefield where radioactive exhaust was just an acceptable cost of doing business. The NB-36H stands as a warning to modern aerospace engineers. Just because you can put a reactor on a plane doesn't mean you should. The laws of physics might allow it, but the laws of biology and common sense strictly forbid it. The silence that followed the cancellation of the nuclear aircraft program was deafening. Thousands of pages of test data were locked away in classified vaults, only to be partially released decades later. What we now know is that the NB-36H was far closer to a catastrophic incident than the public was ever told. Several flight logs mention cooling flux irregularities that could have easily led to a mid-air meltdown over populated areas. We were lucky. The fact that the Crusader completed 47 flights without leaving a permanent crater in the American Southwest is a miracle of sheer luck rather than perfect engineering. It was a gamble played with the lives of millions, all to prove a point that was rendered obsolete the moment the first ICBM left its silo. Today, the spirit of the NB-36H lives on in the whispers of new nuclear-powered propulsion systems for deep space travel. But for the Earthbound, the Crusader remains a ghost of a future that never was, and a future we should be glad we escaped. It remains a monument to scientific hubris, a 180-ton reminder that some powers are too great to be harnessed by wings made of aluminum and lead. The American monster of the skies has been laid to rest, but its radioactive shadow still looms over the history of aviation, reminding us that the sky has a limit, and we reached it in 1955. I want to hear your thoughts in the comments, because this is a question of ethics as much as engineering. If the Cold War had turned hot, do you think the US should have deployed a fleet of these flying Chernobyls, knowing they would poison the very air they were defending? And tell me, what is more terrifying, the 95-ton T-28 tank we discussed earlier, or this 180-ton flying reactor that could have blinded an entire city with one crash? If you survived this deep dive into the radioactive heart of American history, hit that subscribe button and leave a like. We are the channel that uncovers the machines that were too dangerous to exist. See you in the next one, if the Geiger counters stay quiet.